Hi, in this video I'm going to show you how I designed a file to make a flight case for a Z head. Okay, so here is the basics of the file that I've designed. Okay, so to help me I've used the box creator in the Gadget section. So what I'm going to do is I'm going to very briefly go over to the Vectric's website and we're going to have a look about how any VCarve Pro user can download this box maker gadget for themselves. Okay. So I've very briefly searched it. I've downloaded the gadget via this one here. And this gadget now sits on my desktop. As you can see, there are many free of charge gadgets for your VCarve software. You can just download them as you need. So I'm going to quickly load up a brand new file. And in this, our parameters are going to be a full 8 foot by 4 foot sheet at 1/2 inch or 12 millimeters thick. And we're going to open up the box maker gadget. And the window looks just like this. So one thing to be aware of is the box maker gadget will always work to the outside dimensions of your box. So for our Z head flight case, we are going to be working to the inside measurements of our box, plus our material thickness, plus a small amount for allowance. So as follows, the width of our Z head flight case would be 280 millimeters wide. The depth of it would be 300 millimeters wide, and the height of it is 510 millimeters wide. So we are going to make our joint width 50 millimeters per finger joint. And for the purposes of this box, we're going to make those square tabs, which is located just down here. And we actually want a tabbed lid also. So over here, you can see that there's faces to be machined. You can select and deselect all of these different faces, okay? And we're going to choose a tool. For this particular operation, we are going to choose the 6mm solid carbide end mill. So the only other thing to pay particular attention to is this allowances section here. So I know from mine in particular, I want a 0.15 allowance, okay, but your machine may differ. So every single machine out there is going to be like a vehicle. You can take two exactly the same vehicles from the same brand, but they may drive slightly differently. So you may want to play with these allowance features to suit your machine and your cutter. So once you've got all your parts selected, you press OK. And mine I've set to a line here. So I can select all of my parts and I can move them around on the screen. And as you can see, the gadget will pre-make your toolpath. So all my cuts are set outside of my material allowance. So to change this, I just right click, go down to recalculate, and I'm going to ask it to recalculate all toolpaths. So now all my components are snapped to fit inside of my 8x4 sheet. So there's a couple of things to be aware of with the box maker gadget. Okay, so firstly, this was made for imperial versus metric. So your thickness for your tabs will always be 0.025, which 0.025 of an inch isn't necessarily an issue, but 0.025 of a millimeter is going to be tiny. So we're going to change that to 6 millimeters. And the length of the tabs at 50 millimeters is too big. So we're going to make that down to 15. So we're going to have a 15 by 6 tab, and we'll change that to 3D tabs also. Now, another thing to be aware of is the ramps section will always default to a 100 millimeter ramp, which is just far too long. So you think even in inches, that's going to give you a 100-inch ramp, which is just ridiculous. So we're going to change that to 10 millimeters. Okay, so they're the only real two things to look out for. So if we recalculate that now, you can see that my tabs are much smaller and my ramps are something more acceptable. So we've made a basic 6-sided box. So now if we revert back to the file that I've already designed for our flight case, we can talk more in detail about this specific file. So first thing to note is I made some test cuts for my pockets to accept the 12 millimeter rebates, okay, which are detailed over here. Now, this is going to be to accept this portion of the file, which is going to sit into the side of our case and give us an aperture for 2 spindles, a stylus, the collet spanner, and the T-hex spanner. Okay, so really simply, I'm going to open this up here and we will open the previews. And as you can see, I've created all the toolpaths to suit a 6 millimeter end mill, and all of the toolpaths have been highlighted and separated here to each operation for you. Okay. So again, what you can do to reorientate these pieces is you can move them around anywhere on the screen using your arrow keys, or if you double click on there, you can use your cursor to move them anywhere on the screen. Once you have these components where you want, you come over to your toolpaths, right click, recalculate, and you can recalculate a singular toolpath, or it's just easier sometimes to recalculate them all. Okay? So as you can see, when I come back to our preview, I'll reset the preview again, and then we'll run that, and you can see our parts have correctly orientated to our new locations. Okay? So if you're going to design a box from scratch, a couple of considerations is with the finger tabs, if you are very closely located to the edge of the sheet, you could end up with breakout and singular parts then falling off the edge of your material. Furthermore, any parts between two vectors that don't have correct support, again, will break out and can come loose in the middle of your project. So it's always worth looking at your toolpath and looking at your tabs and making sure that you have correct orientation on your tabs to give each of your components correct support.